A quiet patch of warm tropical ocean can become the birthplace of one of the most powerful weather systems on Earth. But a cyclone does not appear from nowhere. It needs several ingredients to line up at the same time. The first ingredient is warm water. The Bureau of Meteorology says tropical cyclones generally need sea surface temperatures above 26.5 degrees Celsius. That heat increases evaporation, loading the lower atmosphere with water vapor. When moist air rises, it cools, and the water vapor condenses into cloud and rain. That condensation releases hidden heat, called latent heat, back into the air. This extra heat makes the air rise even more, helping the pressure at the surface fall. As the pressure drops, more air is drawn in, bringing in even more moisture from the ocean. This feedback can help a weak tropical disturbance deepen into a tropical low. But warm water alone is not enough. The thunderstorms need to become organized near the center of the low. Tall cumulonimbus clouds act like engine towers, lifting heat and moisture through the troposphere. If the storms stay clustered, the circulation can strengthen. If they are scattered or blown away, the system struggles. Rotation is the next key ingredient. The Coriolis effect turns air as it flows toward low pressure. Without enough of that turning force, air simply rushes inward instead of wrapping around a center. That is why tropical cyclones rarely form right on the equator. Farther from the equator, the Coriolis effect is stronger and the storm can begin to spin. Around northern Australia, the monsoon trough and the intertropical convergence zone often provide the starting disturbance. Trade winds meet, air is forced upward, and thunderstorms become more likely. During the Australian cyclone season, usually from November to April, forecasters watch these tropical lows closely. For development to continue, the atmosphere must also stay fairly upright. Vertical wind shear is the change in wind speed or direction with height. Strong shear can tilt the storm, pushing thunderstorms away from the surface low. Low shear lets the system stay stacked, so the warm core can build over the circulation. A tropical cyclone is called a warm core system because its center is warmer than the surrounding air. That warmth comes from repeated bursts of condensation inside the storm. As the warm core strengthens, pressure falls further and winds increase around the center. Under Bureau of Meteorology classification, a tropical cyclone has sustained winds of at least 63 km per hour. Not every tropical low reaches that point. Dry air, cooler water, strong shear, or poor organization can stop development early. That is why warnings consider the whole environment, not just one number. The simple version is this: warm seas provide fuel, rising moist air powers thunderstorms, rotation organizes the flow, and low shear keeps the storm upright. When those ingredients keep reinforcing each other, a tropical low can intensify into a tropical cyclone.